For hundreds of thousands of years, woolly mammoths ruled the frozen world. They marched across icy plains in great herds, shook the ground beneath their feet, and carved their presence into both the land and the human imagination. And then suddenly they were gone, extinct. What happened to these giants? Was it the warming of the earth at the end of the Ice Age? Was it the rise of human hunters with stone spears? Could disease, chance, or even catastrophic events have played a role? Tonight, we follow their trail, from the grasslands they once ruled, through the forces that shaped their downfall, and into the future, where scientists ask, could the mammoth ever walk again? The woolly mammoth was one of the most iconic animals of the Ice Age. Standing up to 13 feet tall at the shoulder and weighing 6 tons, it rivaled the largest elephants alive today. Its long, curved tusks could reach 15 feet in length, longer than the height of most men. Its body was covered in 2 layers of fur, a dense undercoat, and long guard hairs that waved like banners in the Arctic wind. Beneath its skin lay a thick blanket of fat, a natural insulation against brutal cold. Everything about the mammoth was a masterpiece of adaptation. It was built for survival in one of the harshest climates Earth has ever known. They lived across a vast region scientists call the Mammoth Steppe. This was a landscape unlike anything we see today, a massive belt of treeless grassland stretching from Spain across Eurasia, over Siberia, and into North America. Imagine an endless ocean of grass, dotted with herds of bison, horses, and reindeer. And above them all, the mammoths. For humans, they were more than just animals. To Paleolithic hunters, a single mammoth meant survival. Food, hides for clothing and shelter, bones for tools, and even house frames. Archaeologists have uncovered villages in Ukraine built almost entirely from mammoth bones, covered in the skins to keep out the cold. In the flickering firelight of caves, humans painted mammoths alongside lions and bison. Not crude sketches, but detailed, elegant portraits. These weren't just prey, they were symbols woven into the earliest stories people told. So why is their extinction such a compelling mystery? Because they were survivors. Mammoths had endured earlier climate swings. They had outlasted predators, ice ages, and environmental upheavals before. Yet about 10,000 years ago, they began to vanish across their vast range. Within just a few thousand years, one of Earth's most successful large mammals was gone. The mystery deepens when we learn that some mammoths survived much longer than most imagine, living on remote Arctic islands until just 4,000 years ago. That means mammoths were still alive when the pyramids of Egypt were being built. Civilization was rising, while in far-off corners of the world, the last mammoths quietly walked into history. What could bring down such giants? Scientists have put forward many theories, but most agree it wasn't just one cause. Instead, it was a combination, a tightening vice of pressures that, together, made survival impossible. Over the course of this film, we'll investigate those pressures one by one. We'll begin with the most obvious suspect, the dramatic warming that ended the Ice Age. We'll watch the mammoth's world shrink as forests spread and grasslands disappeared. Then we'll follow another force, humanity itself. With fire, tools, and cunning strategies, we entered mammoth country and the balance of power shifted. We'll consider other factors, the role of disease, the dangers of dwindling genetic diversity, and even controversial theories of sudden catastrophe. We'll travel to the remote islands where mammoths made their last stand and ask what their survival and final extinction can teach us. Finally, we'll look to the present. In labs across the world, scientists are working to revive the mammoth, or something like it, using ancient DNA. Should we bring them back, or should their story remain a warning from the past? The extinction of the woolly mammoth is more than an ancient puzzle. It's a mirror held up to our own age, a story of climate change, human impact, and the fragile balance between survival and loss. So let's begin. Let's step back into the Ice Age and walk beside the giants. The prime suspect, climate change. To solve the mystery of the mammoth's disappearance, we begin with the most powerful force of all, climate change. The woolly mammoth was a creature of the Ice Age, perfectly adapted to the cold. But the world that built the mammoth was not fixed. It was fragile, balanced on the edge of temperature and time. And when the Ice Age ended, that balance collapsed. The end of the last Ice Age. About 20,000 years ago, the Earth began to warm. The great glaciers that had stretched across North America, Europe, and Asia started to melt. Rivers swelled, seas rose, and landscapes transformed. This was not the gentle warming of a spring morning. It was a planetary upheaval. Valleys once carved by ice filled with forests. Lowlands drowned as oceans surged. The Bering Land Bridge, the icy highway that once connected Siberia to Alaska, sank beneath rising seas, cutting off the Americas from Eurasia. For mammoths, the true danger was not ice melting, but what came after. Their homeland, the Mammoth Steppe, was a unique ecosystem. It stretched from Spain across Siberia, all the way to Canada, the largest biome on Earth at the time. Cold, dry, and windswept, it was a sea of grass and flowering herbs, a banquet for grazers. But as the world warmed, this great steppe began to vanish. Trees marched north, invading the open plains. Birch and spruce forests rose where grass once dominated. Wetlands spread across the ground, fed by melting snow and rain. What had been dry and grassy became damp and woody, and mammoths, creatures of the open steppe, found themselves trapped in a shrinking world. Loss of habitat and food sources. Picture a mammoth herd grazing across endless grass. Calves tug at their mother's fur as adults sweep snow aside with their tusks, exposing shoots of sedges and grasses. This was their world, a grassland so vast it could support millions of animals. But grass needs space and dryness. It needs wind to keep soil firm and cold to prevent trees from taking root. As forests spread and wetlands formed, the nutritious grasslands declined. What replaced them, shrubs, mosses, woody browse, could not sustain giants. The change was slow in human terms, but rapid in evolutionary time. Within just a few centuries, landscapes flipped. Where herds once roamed freely, patches of forest closed them in. Where matriarchs once led calves to familiar feeding grounds, they found waterlogged marshes instead. And the effects cascaded. Calves grew weaker. Adults struggled to find enough food through long winters. Reproduction slowed. Populations dwindled. The mammoth, once the engineer of the grassland, now lived in a world where its very presence was out of place. Evidence for climate stress. The evidence for climate change as a driver of mammoth decline comes not just from imagination, but from science. Paleobotanists study fossil pollen grains preserved in lake beds and soils. These tiny records reveal how landscapes change. Where grass once dominated, birch and spruce pollen suddenly appear in abundance. The plant world shifted, and with it, the fate of its largest grazers. Isotopic analysis of mammoth teeth tells the same story. By measuring chemical signatures, scientists can track changes in diet. The results show mammoths eating less of the high-protein grasses they relied on, and more of the woody, less nutritious plants that replaced them. Population studies confirm the pattern. In regions where warming hit hardest, mammoth numbers plummeted. Around 12,000 years ago, their range began collapsing into scattered pockets. The once vast empire of mammoths fractured into shrinking refuges, cut off by rising seas, spreading forests, and unstable climates. Climate did not kill mammoths overnight. It eroded them, year after year, like waves against stone. And yet, even in this harsh new world, some held on. Their story might have ended here, with the steppe dissolving and the herds fading quietly. But another force was moving through the tundra, one with fire, tools, and hunger. The growing shadow, human impact. Climate change set the stage for the mammoth's decline, but another player had entered the Ice Age world, a species armed not with tusks or claws, but with fire, tools, and imagination. Humans. And wherever we went, mammoths soon disappeared. The arrival of humans in mammoth territory. For much of the Ice Age, mammoths roamed without facing our kind. But as humans spread out of Africa and into Eurasia tens of thousands of years ago, we entered mammoth lands. By around 40,000 years ago, our ancestors had pushed deep into Europe and Siberia. By 15,000 years ago, we crossed the Bering Land Bridge into North America. Every step of that journey brought us face to face with the mammoth. Archaeological evidence confirms the encounter. In caves like Chauvet in France, mammoths appear in paintings more detailed than almost any other animal. In sites across Siberia and Ukraine, their bones are stacked in strange patterns, suggesting humans not only hunted them, but built with them. Whole dwellings framed with tusks and rib bones once sheltered people from the cold winds. To us, the mammoth was more than a beast. It was a walking warehouse of resources: food, clothing, tools, and art. And unlike other predators, humans weren't limited to tooth and claw. We had strategy, hunting strategies, and efficiency. Imagine a small band of hunters standing in the snow, spears ready. They are lean, wrapped in hides, their faces streaked with ash. Ahead, a mammoth herd grazes in the weak winter light. The hunters whisper, signaling with hands, moving into position. Then, with a sudden shout, they drive the animals toward hidden pits or into a riverbank where escape is difficult. Spears fly, chaos erupts, and slowly one giant falls. These hunts were dangerous. Many hunters surely died trying. But when successful, the rewards were immense. A single mammoth could provide several tons of meat, enough to feed dozens of people for weeks. Its hide became clothing and shelter. Its tusks became tools, needles, ornaments. No part of the animal was wasted. Over time, humans developed better techniques. The atlatl, a spear thrower, extended the arm and launched projectiles with deadly force. Coordinated drives funneled herds into kill zones. Fire may have been used to guide animals or drive them into traps. What mattered most was not the weapon, but the brain. Humans coordinated, shared knowledge, and passed it on. Each generation became better at finding, tracking, and killing mammoths. For an animal already weakened by shrinking habitat, even occasional hunts could have devastating consequences. Evidence for human hunting. The archaeological record is clear. Humans hunted mammoths. At sites across Europe and Siberia, mammoth bones show cut marks from stone tools, fractures from marrow extraction, and spear points embedded in ribs and skulls. On the Great Plains of North America, Clovis points, finely made stone spearheads, have been found alongside mammoth remains, evidence of organized hunts. Some sites reveal something more striking: concentrated piles of mammoth bones, far too many to have died naturally. These were kill sites where groups of humans may have slaughtered entire herds. Skeptics argue that humans could not have hunted mammoths to extinction on their own. After all, Ice Age hunters were relatively few compared to today's populations. But this argument misses the point. Mammoths reproduce slowly. A cow carried her calf for nearly 2 years before giving birth. A female might raise only a handful of calves in her lifetime. Even a small increase in adult deaths could tip the scales toward decline. And humans didn't just kill, we disrupted. We camped along rivers, lit fires that changed vegetation, and blocked migration paths. We were a new force in the ecosystem, and the mammoth, despite its size, was unprepared. The synergistic effect. So were humans solely responsible for the mammoth's extinction? Probably not. Climate had already squeezed mammoths into shrinking pockets of habitat. Populations were fragmented, food was scarcer, calves were weaker. Into this stress system stepped humanity, a predator unlike any the mammoth had faced before. Together, these pressures formed a lethal partnership. Climate narrowed the stage. Humans delivered the final blows. This synergy is why scientists believe mammoths vanished so rapidly. Climate alone might not have destroyed them. Humans alone might not have either. But together, they created a world where giants could no longer endure. And yet, even with humans pressing at their flanks, mammoths held on longer than most imagine. For thousands of years after the main populations collapsed, small groups still walked the earth. Their story continued in hidden corners until even those last echoes faded. The role of disease and other factors. Climate change reshaped their world. Humans hunted and disrupted their lives. But for a species to vanish entirely, sometimes more subtle forces must also play their part. Disease, genetics, chance. The mammoth story is no exception. Disease. We know that in modern ecosystems, disease can strike even the strongest populations. A virus can race through herds of elephants. Parasites can weaken already stressed animals. For mammoths, direct evidence is scarce. Diseases rarely leave clear traces in bones. But some scientists believe that as populations shrank and scattered into smaller groups, the risk of disease outbreaks grew. Imagine a weakened herd, already struggling to find food in shrinking grasslands. A parasite spreads among them, sapping their strength. Or a virus leaps from another Ice Age animal. In a vast, healthy population, the illness might have been absorbed. But in fragmented, fragile groups, the toll could be devastating. We may never know exactly what pathogens mammoths faced, but we do know this. Stress from hunger and isolation leaves animals more vulnerable to disease. And in the twilight of the mammoth, vulnerability was everywhere. Genetic bottlenecks. There is another hidden enemy, genetics. When a population falls below a critical size, diversity is lost. Harmful mutations accumulate. Fertility declines. Calves are born weaker, less able to survive. Scientists call this a genetic bottleneck, and the last mammoths passed through one. DNA recovered from mammoth remains tells a sobering story. Late populations carried unusual mutations, including genes linked to fertility and the sense of smell. Some researchers suggest these mutations may have impaired their ability to reproduce or even altered how they experience their environment. On Wrangel Island, home of the very last mammoths, genetic studies suggest the population was reduced to just a few hundred individuals. Within such a small pool, inbreeding was inevitable. Over generations, resilience faded. Even without hunting or habitat loss, genetics alone may have pushed them closer to the edge. It is a reminder that extinction can arrive not with a bang, but with the quiet failing of bloodlines. Catastrophic events and theories. Some theories point to sudden, catastrophic events. Around 12,800 years ago, the Younger Dryas period began, a sharp return to colder conditions. A controversial hypothesis links this to an asteroid impact, one that may have devastated ecosystems across the northern hemisphere. But direct evidence for a single impact ending the mammoth is thin. Mammoths were already in decline long before this cooling, and after small populations continued to survive for thousands of years. The asteroid idea makes for a dramatic story, but the reality is subtler. Mammoths were undone by a web of pressures, not a single cataclysm. Weaving the threads together, disease, genetic weakness, and bad luck may not have been the prime killers, but they mattered. A harsh winter at the wrong time, a new illness, a herd too small to recover from losses. Each was another thread in the rope tightening around the species. By themselves, these forces might not have doomed the mammoth, but alongside climate change and human pressure, they helped close the final chapter. The great herds were gone, but a few pockets endured, survivors on remote islands, out of reach of the mainland's troubles. Their story would stretch thousands of years beyond the rest. The survivors in the final decline. For most people, the story of the woolly mammoth ends 10,000 years ago, at the close of the Ice Age. But the truth is stranger and more haunting. The mammoth did not vanish all at once. Small, isolated groups survived long after the great herds had disappeared. On two remote islands in the far north, the echo of giants lingered for thousands of years, the last strongholds. One of these sanctuaries was St. Paul Island, a rugged patch of land in the Bering Sea, cut off from Alaska as sea levels rose. Here, mammoths survived until about 5,600 years ago. That means they were alive while ancient Sumerians built the first cities of Mesopotamia. The other refuge was Wrangel Island, lying north of Siberia, locked in by ice and sea. There, astonishingly, mammoths survived until just 4,000 years ago, when pharaohs ruled in Egypt and the Great Pyramid at Giza already stood. Think of that. Pyramids rising in the desert sun, while far away, in the frozen north, shaggy mammoths still trudge through the snow. Why did these islands preserve them? Isolation played a key role. With sea levels cutting them off, humans had little access for much of this period. Predators were scarce, And though the islands were harsh, they offered enough tundra and grass to sustain small herds. In these refuges, the mammoth story carried on quietly out of sight of history. The fall of St. Paul Island. On St. Paul Island, the end came not from hunters but from water. As the climate shifted, the island's freshwater sources dwindled. Ponds shrank, streams dried, and the surviving mammoths faced a slow and merciless thirst. Bones recovered from the island tell of populations dwindling as fresh water became scarce. By about 5,600 years ago, the last mammoth had fallen, not to a spear, not to ice, but to the simple, inescapable need for water. It is a quiet, almost tragic ending, a reminder that extinction can come not with violence, but with absence. The fate of Wrangel Island. Wrangel Island tells a different story. Here, mammoths endured far longer, but at a cost. Genetic studies show the Wrangel population was tiny, perhaps only a few hundred animals at most. In such isolation, genetic diversity collapsed. Harmful mutations spread. Scientists believe these late mammoths suffered from reduced fertility, weakened senses, and perhaps even strange physical traits. Yet still they endured, holding on for thousands of years after their cousins on the mainland were gone. Their survival is astonishing, but their small numbers made them vulnerable to even the smallest change. What finally ended them remains debated. Perhaps a storm devastated their food supply. Perhaps disease swept through the herd. Perhaps at last humans arrived on the island, bringing hunting and fire. Whatever the trigger, by about 2000 BCE, the mammoths of Wrangel Island were gone, and with them, the final chapter of a species that had once ruled half the earth. Lessons from the last survivors. The survival of mammoths on these islands is more than a historical curiosity. It teaches us about extinction itself. Even when a species appears gone, fragments can linger, hidden in isolated pockets. But such populations are fragile, vulnerable to thirst, storms, genetics, or a single misstep. They can survive for centuries, even millennia, and still vanish in an instant. The story of St. Paul and Wrangel is not just the end of mammoths. It is a lesson in how extinction works. Slowly, unevenly, then suddenly, completely. The legacy of the woolly mammoth. The woolly mammoth may be gone, but its story did not end with its last breath. Its bones, its art, its DNA, all echo across time. The mammoth left behind more than tusks in the ice. It left a legacy in science, in culture, and in the way we see our own future. Scientific significance. Extinction of the woolly mammoth is one of the most studied in history. Why? Because it holds lessons about our planet and ourselves. By studying pollen trapped in ancient soils, we learn how landscapes shifted as the Ice Age ended. By analyzing isotopes in mammoth teeth, we trace their changing diets. By sequencing fragments of their DNA, we see how populations declined, mutated, and collapsed. Each discovery adds to the puzzle of how great animals fall. Mammoths teach us that climate change is not an abstract idea. It reshapes the land, the plants, the animals, everything. They show us that even the strongest species can vanish when conditions shift too quickly. And in today's warming world, where elephants, rhinos, and countless others face pressure from both climate and humans, the mammoth's fate feels less like history and more like a warning. Cultural impact. But the mammoth lives not only in science, it lives in culture. Tens of thousands of years ago, humans painted mammoths on cave walls, carved them into ivory figurines, etched them into stone. These were not idle doodles. They were acts of reverence, of imagination. The mammoth was food, but it was also myth, a presence in the human mind as much as on the tundra. That presence never left. From folklore to modern films, from museum halls to children's books, mammoths remain icons of deep time. They represent endurance, majesty, and the tragedy of loss. We see them as both real and mythical, giants that walked with us, then slipped into story. In this way, mammoths are bridges, bridges between science and art, between the human past and the human present. They remind us that extinction is not only about biology, it is also about memory and the power of imagination. The question of de-extinction. Perhaps the most surprising part of the mammoth's legacy is this: it may not be over. In labs today, scientists work with mammoth DNA recovered from frozen remains. Using CRISPR gene editing, they aim to splice mammoth genes into the genome of the Asian elephant, its closest living relative. The vision is to create cold-adapted hybrids that resemble their Ice Age cousins. The reasons go beyond curiosity. Some ecologists argue that reintroducing mammoth-like animals to the Arctic could help restore grasslands, slow permafrost thaw, and reduce greenhouse gases. In this vision, mammoths would not only return, they would help heal the Earth. But de-extinction raises questions. Should we bring back an animal whose world is gone? Would such creatures truly be mammoths or only echoes? And could the money and effort be better spent protecting the elephants, rhinos, and other giants we still have? The debate itself shows the mammoth's power. Thousands of years after their extinction, they still shape our imagination, our science, and our ethics. Lessons for today. The mammoth's story is not only about the past, it is about now. They show us what happens when climate shifts faster than species can adapt. They remind us of the impact humans can have. Even small populations with simple tools can change the fate of giants. And they warn us that extinction is permanent, irreversible, final. But they also inspire. The art they left in caves tells us of awe and wonder. The science we draw from their bones teaches us resilience and fragility. And the debates about their return remind us that we are custodians of life, with choices that echo into the future. The mammoth is gone. Yet in memory, in science, in story, it still walks beside us. The story of the woolly mammoth is not one of a single villain, nor of a sudden catastrophe. It is the story of many forces converging. As the Ice Age ended, the world warmed. Grasslands shrank, forests advanced, and the vast mammoth steppe dissolved into fragments. Mammoths, once masters of the cold plains, were left with fewer and fewer places to stand. At the same time, humans spread across their range. With spears and fire, with knowledge passed from generation to generation, we became hunters of giants. Even small pressures from people added to the burden of a species already weakened. Disease may have struck, genetics certainly faltered, and in the end, isolation finished what climate and humanity had begun. On distant islands, the last mammoths lingered until only 4,000 years ago, long enough that their trumpets echoed while pyramids rose in Egypt. Together, these forces braided into a rope that tightened until the mammoth story ended. Not in a single dramatic moment, but in a slow, uneven decline, until the world's great, shaggy giants were gone. And yet, the mammoth has never truly left us. It lives in cave art, in stories told by ancient fires, in the bones that surface from thawing permafrost, and in the imagination of scientists who wonder if it might one day return. Its legacy is both warning and wonder, a warning of how quickly ecosystems can collapse and how human hands can tip the balance. A wonder because even in extinction, it continues to teach us, to inspire us, to connect us to a world long gone. The question is not only what happened to the mammoths, the question is what happens to us and to the giants that still remain. Will elephants, rhinos, and polar bears share the mammoth's fate? Or will their story end differently because we chose differently? If you've enjoyed this journey into the Ice Age, let us know your thoughts in the comments. Do you think mammoths should be brought back? And what other ancient creatures would you like us to explore next? Be sure to like this video, subscribe to Echo of Time, and hit the notification bell so you don't miss our next story from the deep past. The mammoth's voice may have gone silent, but its echo remains. And if we listen closely, it might just guide us forward.